Hello, everybody, and welcome. Good morning, good evening, good afternoon, and thank you for joining the Neo4j training series, the final part, the final episode of this, this edition in the beginning of 2023. We started out with an intro to Neo4j. We went on to doing some intermediate cipher and continued with routing application building last 2 weeks ago. And now today we talk about Spring Data with Garrett. Hi, Garrett. How's it going?
Hi, nice to be here. Perfect. Doing well. Happy to share a little bit of knowledge today. Yeah, I hope you can hear me well.
I can hear you well. I can see you well.
Perfect.
Everything looks fine. This is obviously live on the internet, Big Marker, as well as on LinkedIn, Twitch, and so on, and YouTube. So if you're watching this live now, we will have some time for Q&A. So if you have any questions for Garrett on anything he's presenting, then type it in the Q&A panel on Big Marker. If you watch it outside of Big Marker, please be aware that we have to prioritize the questions from the registered users. But if we have some time, we can squeeze something in, depending on the flow today. Obviously, this session is going to be recorded, so don't worry if you have to jump off early or if you miss some stuff in the beginning or some of the training part is a little bit too fast for you maybe, then you can always jump back to the recording and do it later on again, as well as the slides. We will share the slides with you also later on, so that means you can continue or proceed through the training in your own time and your own pace. So it's going to be a problem. I'm really happy to have you all here today. Like I said, use the chat for your questions, for your comments. Use the Q&A for your questions, and use the chat for your comments. If you like what you're seeing, it's always good to get some feedback on the training. I see people from Colombia, from Nuremberg, from the Netherlands. So a couple of countries are around, so good mix. Hope you have a good time. And with that, I think I got the logistics out of the way, and I'm happy to hand it over to you, Garrett, for the training.
Yeah, thanks. So hello again from my side. The slides are there, perfect. So this is also pretty new to me. So lately I just had presentations virtually. So please forgive me if something does not sound this fluent as it should. But I hopefully am also set up with all the logistics and technology here. Great. And I hope you are also set. First of all, welcome. And who are we? Sadly, just me today, Garrett, also working with Michael Simons in the team Spring Data Neo4j and Neo4j Object Graph Mapper. You might have already spoken with us. Happy to see you again. And if you don't know us, we are two people creating Spring Data Neo4j and Neo4j OGM and trying to also get involved into community events, etc., to give you much more knowledge about how to use it, best practices, etc. But today we will focus on getting you started and up to date with SDN. So that's from us. So who are you? So as Alex already mentioned, there are a few people from Colombia, Netherlands, Germany, UK. Just spam in this chat. Where are you from? What are your profession? I already experienced with Spring Data Neo4j and such things. Would be good to hear from you. Regarding the chat and the Q&A section, we have a little bit of stuff planned today to get you up to speed and running. And what you can see is that we have this blue marked topics. That's where you are also involved. So I cannot check, but if you want to, you have a little bit of time to try those things out along with me presenting it. The sections are so planned that if you have some kind of practical part, I have some time to look over the questions and could answer them before we look into at my screen to see some solutions or a possible solution for a problem. So yeah, this is the roadmap for today. So first of all, we just make sure that you are set up. If you're watching the recording right now, you can then skip ahead to see if you are really set up with all the dependencies. Then we will create a small application and make it use later on Spring Data Neo4j, so we can see some kind of evolution in our application, but also learn a little bit about the architecture that we are trying to ensure when we established the new Spring Data Neo4j a few years back. What is the benefit? What might be the negative effects on loading massive data and getting it mapped and such things? So we will discuss this. Also, later on, we will discuss how to load only a subgraph. So if your model would probably describe a whole graph, how to just get a slice of this with various technologies. Then also we're going a little bit deeper into the topic, how you then handle such objects. And last but not least, but for now, because if you're really new to Spring Data Neo4j or the Spring ecosystem in general, we speak about testing. So, and it would be up to you also to test your application afterwards. So yeah, let's just jump into this.
So Garrett, one quick thing. Could you click on this little hide button where you share your screen, which says the little at the bottom of your screen, where it says, yeah, there, exactly. It goes away. Cool.
If this annoys you, yes, of course. So yeah, if you want to code along, it would be the best if you have a free Aura instance running. If you haven't done this yet, and just wait a second, it would good to have the movie example dataset running. If you're not using Aura or don't want to use Aura, or you have only the free account and you already have a free Aura instance running with your data, you could also use the server edition or Docker. So how this will get set up with Docker, I show you in a second, and also how to import the movie example dataset with just a few clicks. Then, and this is something we cannot work around, is JDK 17. So this is required by the newest driver and also by the newest Spring Boot versions. So it's up to you which vendor you choose, Eclipse, Azure, or Oracle, or OpenJDK. Then it would be much easier to run your application when you have an IDE setup, like IntelliJ or etc. I don't give support for Vim or NeoVim or something like this with LSPs. And yeah, access to Maven Central, because when we load the application skeleton later on, it will download the dependencies from Maven Central if you don't have already proxy configured or something like this. So this would be good to have. Also, and this is also more optional, you would have to have Docker for testing. There are alternatives. Today, I would prefer, depending on the time we have in the end, to just use a Docker-based solution for testing. If we have enough time, I'll also show you how to test this without Docker and just Neo4j test harness dependency. And yeah, those are the requirements. I think if you're doing this on a daily basis, nothing new for you. But yeah, just to be sure that you're all set up and I don't surprise you with any requirements later on. Yeah. So this is what I mentioned. If you click the Aura database, you should then choose the movies example instead of the empty database. So to get started and to have something to play around, I have a link for you. If you don't want to use click this individually, head over to start.spring.io and just create an application. Sorry, whoa. Can you delete this maybe? Alex, I posted the wrong. Thanks. This was the wrong link.
This is the one you.
So,
yeah, okay. Just wanted. Okay, cool.
Yeah, so I'm now also Michael in the chat. So if you click the link, it will download a zip file containing a current version of Spring Boot or the project skeleton with a Spring Boot application inside without any dependencies. It's Maven based. So choose what you are comfortable with. But I will use Maven. Even though Spring Boot nowadays uses Gradle as the default, we will use Maven in this training session. But yeah, choose what you want to have. And extract the zip file if it's not done automatically. And now we have a look at our code for a second, just to see, before we jump into the practical part, how it should look like. So if you have extracted the demo application and you are already a little bit familiar with Spring Boot applications, you should see this common layout where you have the start point, your application properties empty, and an empty test for your application. This one. So if this is set up correctly, you could just in IntelliJ, for example, run the play button, or either use right click and run your application, or the shortcut, just to ensure that everything is running, that there are no side effects, etc. pp. So I'm just assume that you're set up and we are ready to go with creating our first application. So this is a little bit hacky to get back to the slides. So the first practical part is something where I also would like to code along with you, of course, that just mention what I'm doing so you can just follow through. In the next practical parts, then I will take this time to answer some questions if they are occurring or not. So for this, I will just enhance the project skeleton to have a running application that connects to a Neo4j database. So even though we will talk about mostly about Spring Data Neo4j, we will start with a simple application that is just using the Neo4j driver. And it will already give you some insights on how not only Spring Data Neo4j expects the Spring ecosystem to be prepared, but also what Spring Boot already does under the hood without Spring Data Neo4j. For this, we are opening the dependency definition. So for Maven projects, the POM, for Gradle projects, the build Gradle file, and add the dependency for the Neo4j Java driver. Oops. As you can see, we don't add any version attribute here. Sorry. This is because we provided some kind of guidance to the Spring Boot team to get knowledge about this Neo4j Java driver. So they are scanning for the latest versions when they release a new patch version or version in general of Spring Boot. And they put them as a default version in there. So, and that's why using a proper configured IDE is sometimes really good to have. As you can see, I'm overriding an already defined dependency, but now with the version. So, for example, I can see here, per default, this Spring Boot 3.05 application will pull in the driver 5.4.0. This is not the newest driver, and we have now a little bit of options to changes. So either we could set the version explicitly here to say, oh, I want to have the latest version of my driver. Just, for example, use newer features, etc. This is a valid solution. There's also the solution to say, okay, I want to use this as a property, just to have a little bit more focus on where to maintain versions within your POM. And the option 2B, I would say, is to also use properties, but don't define this dependency at all. Because this fixed version we were seeing when we looked into the override is also something that is defined via a property. And for sure, in Gradle, this is working somehow the same way. In Maven, overwritten properties also override the properties defined in dependent POMs or in parent POMs. This means if I define a version property, this one, and I'm probably already using the right naming, here, then it would override the version definition we already had before. So I could also just skip this here again and say, okay, I just want to define that I have these dependencies. Otherwise, the dependency would be optional and wouldn't get fetched by Spring Boot or by my application that depends on Spring Boot. So at least this definition needs to be existent. And after you've put this on your class path, the driver dependency that contains the configuration for the driver, etc., a so-called auto configuration will get kicked in. So it detects that there are several Neo4j driver classes, and a mechanism called Neo4j auto configuration will get issued. There's a little bit of code. We don't go into details here, but the main thing that you should remember from this training is that we will, if not existing, create a bean or an instance and then provide it as a bean of the Neo4j driver. So we already then have something that we can inject, or in Spring terms, auto-wire, into our application. It has some defaults like the URI and the Neo4j user, but it is completely configured via the application properties. So we already see this class here, and we see some kind of string as a prefix, then some properties. There's also an embedded class here, authentication, And this is reflected in our application properties. So the typical place, or at least for local development, the typical place where you define your attributes. So if I use exactly this naming pattern, I have, for example, the chance to say, okay, I want to connect to this UI. I want to provide this username, even though if they are the defaults. And I want to provide this password. So this is the bare minimum you would, for example, need to connect with the credentials you've got from your Aura instance to the database later. As I said, we could, or I will use Docker as an example for not just to give you alternatives, but also to not share or to don't have to care for not sharing my secrets right now to connect to the database. But it would be the very same way for the Aura instances. So now we configured the driver instance. And as I said, if there's no bean that we manually create, and we only have one class that does not create this, we will then have, okay, I do this now how you shouldn't do this, but for brevity right now, we could then auto-wire the Neo4j driver pre-configured into our application. And today we will more or less just stay within this class for the programming logic, so you don't have any switching me around several classes besides later on model classes. And we want to execute our application from here. So after it's started, it should just execute some methods, etc. For this, I will use the command line runner interface. That's something that gets invoked after. So I give you some time to also get this into there, into your application. This is something that gets invoked after the application is set up. So if the Spring Boot application starts, it will configure everything that needs to get pre-configured or auto-configured. And after this, our business logic will run in form of the command line runner right now. It's a start method. So, and here we could use, for example, the driver itself. We could typically, you would try catch here. Sorry. Just to have the right resource handling. Oops. And we can call our first query, where we just return titles of the movies, for example. List as title. And just a second. So we have all the title entries here, and I could just then say for each record we get returned, we want to just print out the titles of every movie. So the interesting part here is not this business logic, but that we can use this pre-configured driver. You will see in a second why this is so beneficial also for Spring Data Neo4j. As I said, I don't have any instance running right now, so I will use Docker to use this. If you want, I just type this manually so that you can also, if you don't want to use the Aura instance or cannot use the Aura instance, follow along. Use Docker with the newest Neo4j version. I'm exposing the HTTP port and the Bolt port here for my local machine because I need to populate the database. I will show you in a bit how this looks like. And also we need to set the credentials. Now the other way around, we defined those in the properties. Now I'm defining those for my actual machine. Just want to have it gets cleaned up in the end. Oh. Wow. And if this was correct, yeah. It checks everything. It creates the database and we are good to go. So looking into the database, I type in the credentials. Nope. And we can see that the database itself is empty. So now we get to the point where we start a guide, so-called guide, the movie guide. And with this movie guide, we are just using this movie guide where you can learn how to make your first steps with Neo4j, and it's built in every database instance to populate our database with some movies and actors, directors, etc. So on the second page, I click on the query. The field will get populated. I execute the query on the play button, and I have a database populated with data. And with this database populated now, I have the movies, and I can finally execute our first application. And as you can see, we're getting the movies back. So this is our first entrance into this code. Don't be in a hurry if you cannot follow with the code right now. You will have a little bit of time. We'll change the code later on. Maybe you can catch up then later. But this is our first step into the world with Swing and Neo4j, so we can really see in which direction this application should evolve. So back to our presentation. So if you want, you could, as I said, take your time, do the practical part. It's already what we everything we've did in the to-do. You can maybe just listen to me continuing this and come back later. You have the recording. You can see the code and implement it for yourself. So the next thing we have to talk about is how is Spring Data Neo4j settled within this broader picture of the architecture. What we have seen now is that the Spring Boot auto configuration for the Neo4j Java driver, at the moment I provide or define this dependency, will create a Neo4j Java driver bean for me. We introduced this also with the not yet anymore so new Spring Data Neo4j, because we thought it might be just, or it is a far more cleaner approach than just having a Spring Data Neo4j auto starter configuring everything. So we said, okay, with our Spring Data Neo4j that we bring to the party, we want to have a starter that also includes an auto configuration that requires the Java driver to be present. That does not necessarily mean that you have to define this manually. We would then require the dependency to the Java driver, but in the end, those are two parts that sit on top of each other. If you want to just use the Java driver within your application, you are fine with just dropping the dependencies, as you have seen this right now. If you want to use Spring Data Neo4j, you are also fine with just dropping the dependencies to the dependency to the Spring Boot starter. And this is the outer picture of how the architecture is layered for this. More interesting is also the internal architecture of Spring Data Neo4j, because we are trying to enforce that the only communication way that we have within Spring Data Neo4j is directed and does not have any shortcuts, but requires us to talk only with our Spring Data Neo4j. Okay, I will use SDN in the future. Our SDN Neo4j client is the only element in our chain of communication that can talk with the Java driver. This Neo4j client, as we defined it, or we named it, is something like a Fluent API Java driver. It has some capabilities for providing mapping functions, etc., that we then make use of later on in this hierarchy, like in the template. This Neo4j client is also something you can use manually. If you have any questions for this, we can have a look later in this training if you want. It's not on the agenda itself to use the client because it looks like the Java driver and it gets more use by the Neo4j template, but it also provides you a little bit of functionality to map some intermediate query or results of intermediate queries manually. The interesting thing on all of those abstractions for data access within this box is they are all running in Spring transactions. That means if you want to change the level of data access or abstraction of the data access within one transaction, you are free to do this. So you could use a repository, then use a client, and then again use a repository within the same transaction. If one will fail, everything will fail. That's pretty good. Also for us to ensure that there are no side effects, as they would or might occur if you were jumping out of this SDN rectangle and using the Java driver directly. So this architecture is something that has been proven now for 3 years or something. And we always advise people to really rethink which layer they need. Everything above the Neo4j client is aware of meta informations about models and classes. The Neo4j client itself is not aware about this and uses and needs some kind of mapping hints or mapping instructions, or what we call binding for parameters functions that the ones above or at most the Neo4j template already provide. But you're free to use the Neo4j client, as I said, as you want. So when we talk about Spring Data Neo4j, and that's what we are here for, we are mostly not talking about using the Neo4j client and don't let SDN map our data, but you want our data to get mapped. So just to get a first impression, and you can type this now if you want. I will type this in a second. I tried to keep it as simple as possible, and we will also flip the relationships later on. But to get the first impression, I created these two classes that describe persons in this scenario, actors, that I named persons because the nodes in the database are called persons, and a movie class. And with this, your meta informations about the node, what's the identifier, where are the relationships, are already sufficient for Spring Data Neo4j to create mapping informations. So it will inspect those classes, even not annotated properties. In this example, we don't have them. We can add them on the go later on. But it will then try to map or create, first of all, queries out of those defined properties and node labels and relationships. And in the next step, for the result mapping, use those meta informations again to create instances of your objects out of the nodes that you get returned. So I think the best is to learn things via coding, not to have this much theory about this. So let us start with now adding Spring Data Neo4j to the project, create our first model classes as we have seen them before, and also our first repository. I think it's, even though we started with the Java driver first, because this is more this independent dependency that we need, I think it's the easiest way to start with Spring Data Neo4j is to use repositories, because you get a handful of predefined methods that you can use, and you can then elaborate from this point to much lower data access abstractions if you need them. I think that's something important. At least I would say it's important to get then this deeper understanding of what you could use, what are possible alternatives, after you've learned about the general functionality, general idea behind this. And yeah, let's dive into this. So the first thing on my list was to use the Spring Boot starter for Neo4j. This means you have to do this nlog in your Gradle build file if you want to. We now add the Spring Boot starter data Neo4j here. We keep it at the default version, but as I said, the Spring Boot starter requires a Java driver. So the Spring Boot starter itself depends on Spring Data Neo4j. Spring Data Neo4j defines then the dependency to the Java driver, to a well-known Java driver version it was tested with, etc. Now we have also still defined the second dependency of the Java driver here. That means within our application, the 5.7.0 version will get used. The good thing is, after we have extracted this property here, that we can now also get rid of the dependency definition itself, because the starter and Spring Data Neo4j defines this dependency. If we remove the dependency definition but leave the definition of the property here, it will still override the dependency of the Java driver. Just to prove that this is working, I refresh the Maven. Sorry, the Maven configuration, and the Java driver is loaded with this version. If I wouldn't use this version, just to have the comparison here, you will still see the older version of the driver. So if you're eagerly waiting for a feature, bug fix, or similar to arrive in the Java driver. And it finally arrived, but there weren't any Spring Data Neo4j or Spring Boot updates in the meanwhile. You can cramp up the version to the desired version and use it. That's something what's the best wording for this? So it's something you don't have to do, but if you really have to, you could use this. Typically, we are bound with one major version of Spring Data Neo4j to one major version of the Java driver. So minor versions can get changed up and down as you want, but we have this fixed dependency on major version to major version. That's the only thing you have to remember when you want to manually define your driver versions. So yeah, since I've defined this here and it won't harm us, I will just keep the 5.7.0 version of the Java driver here. So we have now Spring Data Neo4j as a dependency in here. Let's add our models. For this, yeah, I could use records and I could use the latest fancy Java features, but to get us all around the understanding or need of understanding newer Java features, I will try to use common approach like classes and similar. So the first thing we had was a movie. Where we add characteristic-wise it as a node. For the ID, I'm a little bit lazy. We say the title of a movie is the de facto unique ID. If you want to use other ID types, you could also use generated values without any further informations. We provide generated values for IDs, for long types. That means that we create nodes or load nodes with internal IDs. If we create a node, we wait for the internal ID to get back and set it on the object. Also in the same case when we load the node. You can provide your very own generator class here or a bean reference. So if you have some kind of custom strategy to create identifier, you're good to go also here with your types. You could also use the UUID generator that we provide here if you want to use UUIDs or strings. So we have this string generator, UUID string generator. If you don't want to use the internal identifier, but you don't want to think of any other algorithm for yourself. If you don't provide the generated value, if you don't provide the generated value, SDN will assume that this field is always set in the object itself, if it's a new object you want to persist, or that it's already set within the database, if it fetches, because the ID is the, let's say, only constant that SDN can work with. The other properties are mutable, even though if you define them as not mutable, for SDN, everything is more fragile than the identifier. So as we have seen this here, the movie for now just have a title. And I also make this public because I'm lazy later. And I just want also to read those titles and some actors. Then we need a second class for our actors. And here we are using this special format where we say, okay, we have one label in the database that describes what an actor class is. Because there are no actor nodes in our database, only movies and persons, SDN wouldn't know what an actor should point to. It would query for actors. Instead, we wanted to query for persons. Also, in this case, we are using the name of a person as the fixed identifier because names are so unique. And we will define a relationship pointing towards a movie or a list of movies. We could also, because SDN provides immutable mappings, use final here, and we are good to go. So we have two classes annotated with metadata describing the nodes we want to fetch from the database. So currently we are just talking about querying from the database that are defined there. And now we want to access them. To make use now of this functionality, as I said, just to show you how it would look like maybe in with a pure Java usage, would be the override of the list function within the Java driver. The list function within the Java driver also provides the acceptance of a mapping function. That would mean that I could take a record that comes back, so row by row, record by record, throughout the whole result. That would then get converted into the desired outcome object. So for this, for example, I could say I would return movies and persons with the acted in relationship, and I would create those objects myself. But with SDN, we could just then say, hey, I want to access those data. To use this, to define those repositories, we are creating interfaces which are, or no, we call this actors, actor repository, that are extending from a predefined class Neo4j repository. You can do this in your in a very own file, because to use this here now inline, we would require some configuration that you don't have to do if you require this in your own own file. But for here, I think it's better for you to see without any context switching what we are doing. So we have this person, actor, and it is mapped by the identifier type of a string, because we defined this name. And this is pretty much all you have to do when you're using an own class. For now, here I need to say that I want to also scan for nested repositories. The whole annotation and the property is nothing you would need, as I said, if you put this in your own file. For here, I just use this because this is embedded within this demo application class. And then I can say, instead of using the driver, or just keep the driver here, maybe for later, if you have any questions, I want to get an actor repository injected and use this actor repository now here. So for example, I want to find all movies, all actors, or the first actors whatsoever. Because without defining any method up front, I can already make use of some functionality here. This is something built in within those repositories. So you have not only the option to find things, you can count, you can delete, if you know what you're doing. The interesting bit now, because I've cheated with the identifier, is that I can say find by ID, and I only need to provide the ID/name of an actor, for example. So in this case, I just want to query for Tom Hanks. And I will get, as you might have already seen, an optional back. I'm pretty sure that Tom Hanks is in the database. So I'm just doing this unsecure here to say, okay, I want to find this very actor. Yeah, why not Tom Hanks? And hopefully my font size is good enough, because I now will execute this in debug mode so that we can have a look on the actor, on the actor instance. So I put a breakpoint on Tom Hanks just to get us some kind of inspection. Yes, I could have done this with some string to string generation, but I think for this temporal case, you are good to go and can see this. I don't see any comments here. So we already see it found the actor, Tom Hanks, and it found 12 movies he acted in. So we can see, maybe you can confirm this or not, at least from the first 3 movies, I can say, okay, this is definitely something Tom Hanks acted in. And this is everything Spring Data does more or less automatically under the hood. If you're doing the happy path, if you're having a perfect domain for this, etc. Of course. Let's have a look in the logging for this. So if I turn on the logging for Spring Data Neo4j, let's say to debug, you can also see the queries we generate. So let's start this application again. Please ignore the warnings right now, because these are the new functionality for notifications, because we are asking for fields that are not yet existing within the database. But you can see, for example, here, the query for the actor name, where we hide the information, which property got defined if you're not running the logging level in trace mode. So you can also read everything in the documentation about how we create queries, why we create queries the way they are, etc. So you can see here that we are not just returning the actor or just returning the actor and the movies, etc., or relationships, but we are returning some kind of map projections. This has the benefit of that we can also add some fields that we need as additional, or want to have as additional informations, like I want to have all the labels, but we can also exclude fields that we don't want to see. So we, as you can already see here with the name itself, we can explicitly say, you defined only those properties within your model class, then we will only query for those properties you have defined in your model class, and not for this megabyte-sized string that you also have on the node. So this is something, let's say, a minimal performance optimization that we have in there. Also, with this nested pattern, when it comes to relationships, we group the relationships to this very node and can say, okay, this is exactly the relationships we wanted to have. But these are the created queries. We come to custom queries later where you don't have to write those queries, of course. But we try to optimize as far as possible something like this for you to get the best performance for a general purpose mapper, at least. All right. So we have now this code along demo. If you have any questions to this, I'm happy to answer your questions. There are some questions.
Got some questions. Yeah, I got one here from r.carol. Must one use Java version 17, or are there conflicts with the demo with Java version 19 or with the Spring Boot Neo4j driver?
No, it shouldn't. That's what I can say. If you have looked closely into my one configuration, you can see that I'm also using Java 18, an older version of Java 18, because this is the default version currently installed for my profile. So there shouldn't be any problems with newer versions.
Okay.
But if you have a problem, please shout out. I have the links later, but Spring Data Neo4j is on GitHub. You can file an issue there, and we will have a closer look on this.
Okay.
Yeah.
Cool. And the other one was here from Dextro Energy. In your example, the movies are eagerly loaded. Is it also possible to lazy load relationships?
No, it's not possible. First of all, it was never possible within Spring Data Neo4j since the beginning. It's not like where we have, for example, JPA, Hibernate as an implementation, where you have this lazy loading mechanism deeply built into the framework. But we try to load everything you defined within the scope of the model descriptions, also via relationships, of course, at once into the Java object graph. And also for persistence, we do the same. In hopefully a few minutes, you can see how you can create subgraphs and slice the data. Because lazy loading would enforce us to put some kind of technology. I think in JPA it's still proxies. So we have to wrap the actual objects again and have this tracking mechanisms on them. So if you access them, we will issue queries. But we want also the users of SDN to have control when a query gets issued. And we think for most of the users also using JPA, it's not really transparent when an issue gets queried. I think a prominent example is if you are not using any intermediate classes like DTOs or something like this in your application, and you put, for example, or you make your loaded object visible to the outside, be it a desktop application or even a web application, but with the well-known maybe open session and view filter, you will have the consequences that if users interact with this object, it will then issue database commands. And this is really nothing. We tried, at least, I hope we did it good, to make the amount of surprises a minimum in SDN. So be it surprises what gets loaded, be it surprise when it gets loaded, or behavior-wise in general in SDN. Yeah, and that's why we're not using lazy loading. So it was it's nothing we forgot and nothing we said we do later, but something really we said we won't ever do in SDN. Yeah.
Okay. Thank you.
What did I want to do? Were there another question while I'm thinking of what I wanted to do? Yeah.
I think
Okay.
we had the questions covered for now, but we can obviously, ask your questions, and we will find another
Yeah,
spot
perfectly.
for our
Perfectly.
next
Yeah,
Java
there will
question.
be there will be one. Yeah, so fine. We did this. So this is a practical part for people in the recording. What to do. And this is the slide where I already thought of there is a bug. Maybe you can spot this. So I switched now the relationship definitions from the movie, from the person to the movie. Because in the next part, we will discuss, for example, slicing of data. And it's better to just still have just these two classes where we're working with. And now we hopefully you too, will create a movie repository that will have persons as related entities. And yeah, what I'm missing here is that we can already see this with Tom Hanks, for example, in the example here. That's the acted in relationship. Perfect. Is still pointing towards the movie. So the relationship needs to get defined as incoming here. That's something I just missed in the slides. So also for the future viewer, here you have to define the relationship as incoming to the movies. So I would like you and also me to alter the domain classes now. You can still have the actor repository around, or just delete it. Because in general sense, I would also always advise to just have the necessary repositories in place where you want to use this. There shouldn't be a one-to-one mapping for repositories to entities. Most of the time you have one central entity, like we now have changed our priority to the movie, that will then also fetch the persons. Of course, if you have both use cases where you have both classes as first-class citizens, you practically would write those repositories because you don't want to jump over all the movies to just fetch persons. But in our example case, we now have the movies now as the first-class citizen nodes and the relationships as and the person as the related nodes. So we have some kind of direction in our Java graph. And because the question came up with lazy loading and slicing, I think it comes from slicing data and not loading everything at once, or I don't want to fetch everything. There is functionality on the repositories for slicing this data. That means you can provide your very own custom cipher. For example, you can say you have this. I think we just go in a second again to the code, and I will show you there. You can write this well-known, or let's say a little bit more readable cipher statement, and also SDN will happily understand this, but it will only fetch this this subgraph of data. Yeah, and before I skip to the next slide, I would just like to do this before we get too much input. The next one will be a little bit tougher. So I think it makes pretty much sense if we do this right now. So I just disable the verbose logging here. We have our demo application. And here, oh, that's something yeah, I completely forgot about this. You can advance your repositories with so-called derived finder methods. Sorry, I need to take a step back right now because I forgot about this. Let's say we didn't have to find this. We go back to the database for a second, just to get you all set up, because you don't know, maybe don't know about the domain itself. We are looking at the database for a second. If we have a look at the actors or persons in general, you can see that they have a born date, or at least a year. That's called born. I would like to add this for a second to our person model. So you can see some kind of difference. It was in born. And we can also add this to our list. So I just added the property. It's just the same name. If we would have to define, if we would call it born year or something, you could also manually still define, as we can do this with the nodes, how the property is called within the graph. So sometimes things diverge. The other application that access the data has ruled over your naming, but you don't want to refactor your whole code base. Then you can just add this property annotation and say, okay, this property is called not born in the database. But for this case, we have this born field, and we can just load it there. The reason why I introduced this is that just to show you the derived finder methods is you can also just say find all by and then names of properties. This is pretty powerful, because this is just by a fixed value, but you can also say find all by born greater than between, etc. Also for strings, you can say, okay, I want the string to contain something, but you are still good to go without writing cipher. This is just for the query part where we put your condition, or we translate the condition you are writing here into a cipher query. So for this case, I just keep this find all by born. We take, sorry, need to switch back to the window. We take some arbitrary born date. I don't know, just to be sure that we are not using Tom Hanks again. Mike Nichols, maybe who did not act in any movie, but we have Mike Nichols here, born 1931. Maybe we just do this twice. Find all by born. Maybe there's another person born this date. And we just print this out. Maybe, sorry, we just map the name out so that we can see that the name, at least, maybe there's a second person in there. Sorry, I just put out the function, but we can see this here. Mike Nichols get report. Maybe there was a second person in, or there could have been a second person in there. And we're good to go. So we have now also seen how this might work with those derived finder methods for a second. There's much more. We have this, and probably I will refer more and more today to the documentation. the whole syntax is also in the documentation. So which data type is supported with which clause and what does it mean? Of course, larger, smaller is different than, for example, for dates when we have before or later and such things. Those are supported. But we came here for custom queries, right? So we know with this structure that we have Tom Hanks with 12 movies, and I can say I want to match a person with a certain name. And for this, I just use the standard property placeholder functionality of cipher statements. Person name. And I want to return this actor. Just call it custom query for now, because naming is not. And if I name this exactly for the same. So now it depends on how you compile. And this is vaguely speaking. So if the naming gets preserved or not of your variables and methods. So the way to play safe is to add this additional parameter to say, okay, I have this parameter called person name that you are expecting in the query and this variable. So you don't come to into the situation where SDN provides this query with this property placeholder, but you are missing out of the parameter. And if I would do this, and if I would do this now here, custom query, and we have Tom Hanks again. I'm just doing this here because I want to debug. And we debug again. Here we can already see that I've done something. Oh, we did not return, sorry. We can see, perfect, we still have Tom Hanks fetched. Also the born property gets set. That's because we return the node itself. So we have the Tom Hanks node, but we don't get any movies. And this is because we don't return any movies. So SDN does not know what to do with these movies. Well, yeah, it just does not know that movies exist in the database. It would be the same case as we would return all the movies and there are none. So this means that SDN itself needs some kind of information about this. And just to get this example completely set up here, we say, okay, we have a person with a name that acted in a movie. Perfectly fine. What we now would get back if we just return M would be 12 results, because as you might know, Neo4j will return now a result for each pair. That would leave us with 12 Tom Hanks instances, everyone attached with one movie. The reason for this, why SDN does this, is that we have this immutable support rooted also in support for reactive streams. That means with Neo4j 4, you got this functionality of working or interacting with the database in a reactive fashion. So even at the moment, one result gets returned from the whole record. We try eagerly to map this object. Otherwise, we would wait until the whole result gets transferred, and then we could only start the mapping process. If we have a chain of reactive operations, we would then block until we get all the results back to map everything and then return it. To not interrupt this reactive flow, we have to map our objects at the moment the results arrive. There are some, let's say, convenient functions in the internals of SDN that will try to optimize this, but we cannot, for example, ensure this in the reactive fashion, that this will work. That's why we always say, if you just want to get one node, because you just have one node of Tom Hanks, with a list of movies, you just use Cypher built-in to help SDN also to map those things. If you have looked closely in the database, not necessarily in our modulation of the data, you would have seen that the relationships, there are plenty of relationship types, directed, also reviewed, and such relationship types. SDN, if we would just return this, would still not map the movies. That's because SDN says, okay, I have a relationship here that has a certain name. I want to ensure that these are the movies that that match this certain type. That's why we also have to return the relationships here. Only in this case, SDN would then return the relationships. So starting this again, we can see that Tom Hanks has all 12 movies. And now I speed up a little bit. Because we have, I don't know, I need to check. Yeah, we have plenty of time, but also plenty of topics to discuss here. So now we also completely hydrated the definition of our model. That's good. We don't have any slice of data load, but more or less a subgraph for a certain person. So this is important to know, that you always get the right return pattern within your custom queries. So that SDN, it's not that SDN is so picky, but otherwise, if we would match on every and map on every movie, we could just provide the wrong information. And that's nothing we would do. As I said it before, we don't want to have any surprises within SDN. That why it might surprise you now that you have to define this relationships also. Yeah, and this is the example for custom queries. Back to the presentation. Okay. The other thing you could provide are so-called projections. So this was the topic about slicing the data. Even the custom query is most of the cases a slice of data. You're doing custom queries because you don't want to fetch, in our example, the movies for the actors, or you just want to fetch certain properties of the actor. So, for example, not the born year, but only the name and such things. So projections, they come in different flavors. I will speak about this in a second. Gives you the opportunity to apply some kind of mask, as you would do it with images, over your complete graph, or at least the defined graph from your domain model. So you can say, from this whole graph, I just want to have this slice of data. It gives you the freedom to say, I have 3 relationships, as we have this after we changed our model then in a bit. I have 3 relationships in my model defined, but because two of them have so many entries. I just want to fetch one of those relationships. You can really then imagine it like a mask around this, say, okay, I only want to fetch this dependencies. And the possibilities with projections is also that we have support for nested projections. That means even on multiple levels of relationships, you can still have this fine granularity of defining what should get loaded and what not. We think it's powerful to have this. Of course, it takes a little bit of time to, first of all, get used to the idea, and secondly, to implement those projections. But on the other hand, you get all the freedom that you might need for huge domain models that you maybe have or not. Also, and this is something we need to discuss in later slides, projections help you also to handle this huge amount of data, not result-wise, but broad data when it comes to persistence. So now I have this next practical part where we will switch. That's something I missed somehow in slides to mention this more explicitly, where we switch the domain model. You can try this out for yourself because I need a 1 minute pause to get something to drink. Where you will switch the direction of the relationships definitions in your model and then create a movie repository for this. I will jump in a second to also do this on my machine. But first of all, I just need some more water.
Maybe in the meantime, I can say a few words while Garrett is out. So I hope you enjoy this workshop. Oh, there he is already.
Already back, yeah. The kitchen is just
so quick.
Next door. So.
Yeah, okay. All right.
But you can also say a few words. In the meantime, you know what I will do. I will just alter my model here. Yeah.
Yeah, it's good. No, I just wanted to say if people to see if people like it, if this is helpful, if this is too quick, too fast, too slow. If you know how many of you were already familiar with SDN, we haven't gotten to that, so it would be interesting to see what your thoughts are now that we are in the final half hour or so of this workshop.
I would also be interested in. So, as you can see me typing, I'm altering now the model as we have discussed this a few slides ago, so that we have now the movie class as the leading entity, and then the persons as the related entities. Of course, I could also make some final, but right now just to have this this simple constructor here. it's sufficient. Yeah, and we need a new repository. Just getting rid of this one for now because we only want to use this. And of course, if you still have questions, please go ahead and ask them. I will check them in a bit. All right. So this is working again. I have to look on my own task I created. Find a movie by title with just the actors attached with custom query. And then by projection. Okay. So you've seen already the custom query example, but I will repeat it here. So we are looking for a specific movie. Of course, we could also use a placeholder here. I find cleaner. Maybe it's just personal preference to say I define this later. And for the first time, we are using the optional image because it's something we were sure with Tom Hanks that he acted in movies, but we cannot be sure every time that the relationship exists. And otherwise, if we would put the pattern into the first match clause, we won't get any movie back if there were no actors. And as we have seen this, before we need to return the relationships also. And now I think it's that would have been good if I would know if you're okay with the debugging view or if you want to have a system out for this. You can give me feedback for the next example. Right now I would use the debugging again. So yeah, I do the system out just to have something to have a breakpoint on. So the first task was to create or to get a movie by title with just the actors on this. So no directors or producers. As we have seen now in the refactored model that we have this acted in, directed, and produced relationships that we can also see in the database. So if we if we are looking for the metrics, for example, and expand it, we can also see the directed relationship for the Wachowski sisters We have the acted in and also the producer. But we were only interested in the acted in. If we run this, we see that movie gets populated with the right title, and we also have the actors on there. So, yeah, this sneaky actor that got into there, and the well-known actors. That's good because we lowered the amount of data we want to fetch from the database. So maybe we have hundreds of directors or producers that we are not interested in. So we could slice this data finally. The very same would be true if we're using this interface, this projections. So I just said interfaces. There are two kinds of projections. Those are called closed projections and open projections. Closed projections are interfaces that define a sub or the same amount of properties of the original domain model that you want to fetch your data with. But we have the possibility to really say, okay, this closed projection really wants to ensure that only this gets fetched. For example, if I have a movie projection right now as an interface, I could say, since it's an interface, it needs to have methods and methods named by the property names that you have defined, because you don't have any property definition within interfaces. So this would, for example, match on our movie the name property. It wouldn't, in this case, and we can see this in a bit, it wouldn't fetch the relationships at all, the acted in or directed or produced relationships. But we don't have to write the cipher query for this. We would have to define something like yeah, it just keeps this. Yeah, this open find by name, find by title. Right. Sorry. It just and by defining this return type, I can get the right result projection back. Sorry for this. I don't know. I'm just struggling because IntelliJ said, okay, this is not a valid projection. That's why I was thinking. So if I say find by title, the metrics. So we are making now use of a mixture of derived finders in combination with the projections. This means that everything that we will fetch, or when we create the query, will first go through the return type definition, and the query will then get only assembled with the required fields. So hopefully I did not do anything really stupid here. Put in the debugger here for the movie projection. Yeah, of course. Yeah, and the movie's projection itself, that's why it's looks so ugly, is only a proxy because it's an interface, and the interface cannot get instantiated. But if we have a look into this, so it just says movie projection. Then we get the offering for the get name. I just repeat this if you cannot read this because the font is a little bit smaller than the other ones. Yeah, perfect. Invalid name because name. Oh. Now yeah. Okay. Maybe everybody in the chat were already screaming. Sorry for this. I called the title name here. And yeah, in this way, the author proved you that I'm not faking anything here. So everything is live. Everything can happen. So running this example again, we get the movie projection back. We still have a proxy class around this. So we need to manually inspect what's on this movie projection by calling the get title function. And we can see it's the metrics as a title. So just to show you that it also makes a difference in what we are fetching. I exclude the first query now from our one. I will put in more verbose logging so that we can see the queries again. And rerun this. And you can see, of course not this readable for a screen share. Hopefully you can see this, that we only fetching the movie with by title, and we are only returning as business value the title itself. There is no concatenation of the relationships or embeddings, as we have seen this before with the generated queries. So at this very moment, SDN stops and says, okay, I don't know how to map those further defined properties within the domain class when you just want to have the projection. This is so more or less the same outcome as we have seen this with a custom query. I could now, of course, also say there are persons here, get actors, as we had this before with the directors and producers, that we don't want to see them with a custom query. If I, okay, I need to breakpoint here again. If I put the breakpoint here again, because it's a proxy, I need to execute the get actors method also. And we can see we still have our 5 actors here that we did not have before because the method was also not declared. This is for projections. And now, yeah, I will take some seconds to skip over the questions. Or Alex, did you already?
No. Okay. There was a question from Erchon. Why is it saying in the logs ID is no longer supported?
That's because with Neo4j 5, there were it's not supported. I think it still says supported. It's just it's supported. Yeah. Tough question. Why does it say it here? I have to ask a colleague. So, but generally speaking, so Neo4j with version 5 shifted over to something called element IDs. They are more powerful than just the long ID types. And in the long run, Neo4j, the database, not SDN, wants to discourage users to explicitly access those IDs, but use element ID for this. Spring Data Neo4j is somehow in between. We support also 4.4, the latest minor version of the last major version of Neo4j, where we only have IDs. So we still stick with IDs in the current Spring Data versions. That's why you're seeing those warnings. And this warning is pretty new because it just came out with Neo4j 5.6.
Okay.
So this is something when users tell us about this, that we say, okay, put in a logging filter or something. It's something that just slips through SDN right now because SDN as a whole is not aware about this particular warning because it can only check for this with current versions of Neo4j, not with previous. It's not existing in previous versions. Yeah, and maybe also there are users who want to see this.
No. Okay. There's another one from Michael. Can a field in the model, for example, name, be actually two fields in the database? So first name, family name.
Yeah, we have a field in the model, two fields in the database. Yes, we have something called composite properties. Need to find some entity class. So this means, sorry, I hope that we had an example in the documentation here. Yeah, either composite property, also for the brevity, I just mentioned this here, or you can also introduce a custom type with a custom mapper.
Okay.
That would then, I think we call this then map. I don't know. Yeah, but composite properties should be the first thing you will look for in the documentation. And if you have any questions, please reach out for this.
Cool.
Yeah. Other questions?
There was one more from Edjon. What would be the best mapping strategy when a relationship has attributes?
Okay. Just for Edjon, you all have to now bear with us, with the both of us. Fast example, yes, it's possible. For this, we have only seen, I just wanted to exclude this from the training, because
if it's going too far for
no,
the remaining time.
2 minutes. 2 minutes. Stop the timer. 2 minutes. Okay. We have just seen node-to-node definition of relationships. So we have a movie node and we have a person node. We have something so-called relationship properties that are not really entities in the sense of you can work with them with repositories, etc. But they are, let's say, something in between entities and arbitrary structures. So in this example domain we have here is good to just show this. So, for example, we create now our actor. But our actor is not really a node, so an entity, but is a relationship property. A relationship property needs to have an ID. Since we are still using the internal IDs, we have only the long type. So this is something we just need to get something fixed and known about this relationship property. So in the database sense, about this very relationship, that we don't remove it or something else. And this relationship property needs to have a target node. So the target node is then something, I don't want to call it start or end node when I created this. The target node is where the direction, where the relationship points towards within the Java model. it's not the direction of the relationship, the physical direction of the relationship within the database. In our example here, we have a movie database that has incoming relationships for persons who acted in the movie. But if I would use the actor here, the target node then is the person, because on the other side of the relationship is the person. So I put in the person here, and this is like scripted, right? If I look into the database, I can see on the acted in relationships, whoa, there are properties, which roles the people played. So I can now define those properties also within these relationship properties, because that's the reason why those exist. So I have a list of strings, let's say, and call it roles. And now I have these roles. Yeah, doesn't matter. So if I now load a movie, so with just the actors, and say the actors are also in my project. So it also works with projections. And I want to fetch my actors here. I can then say each actor. Okay, don't do this at home if you're not in a training session, but working with professional code. You have the actor, then the person, and name, because it's only that we know what we're looking, and we have the roles. So I'm so lazy, I just do the blank line here. So it should fetch all actors, the movie title, of course, then the movie as a whole, only with title and actors or persons acted in. It then not only creates entities or instances of the person classes, but also instances of this actor class that works as this actors. Perfect. So yeah, besides email, we can see that Hugo Weaving plays Agent Smith, Lawrence Fishburne plays Morpheus, Carrie-Anne Moss plays Trinity as a role, and yeah, we have Neo. So this is our approach to model this. I hope this is the answer you were looking for.
Yeah, cool. Thank you.
Yeah. I don't have a script here, so I have to look into the slides. What's up next? Yeah. Without any more context switching back to the slides, I can just say, when we load this data now, like the movie projection with actors, or even more this movie instance of the entity class, where we only also have actors on. The problem is that, as I said, SDN does not want to surprise you, that if we persist this entity, SDN says, okay, you want to persist this movie with those actors and this empty lists of directors and producers. I do this for you. And it goes to the database and will remove all relationships that are not existing within your definition. So this might be a pitfall if you don't think this far. But it's also what's your intention. So you described your whole reachable domain, or what you want to reach through your models and meta annotations. You have an object that has data on it, a valid ID, and a few empty lists. SDN does not know at the moment when you want to persist the data that this data were never fetched. It just wants to ensure that the state from your application gets transferred to the graph. So working with partial data or subgraphs could be a pitfall, and this would be also the moment where we switch from repositories to a lower data access abstraction, and these are the Neo4j templates that we have seen before. For example, if I would now persist, for example, this movie, this custom query, or by projection, I cannot even save this projection right now. So given the point, I have this custom movie here. Oh, sorry. Yep. Where we know that this custom movie is really incomplete, but I have this instance in my head. But it has all actors fetched. This is good. So I can then say I will use the Neo4j client, and the Neo4j template gets also created as beans. Sorry, I forgot this when I mentioned the architecture. So for repositories to work, we have to have a created Neo4j template bean. For the Neo4j template bean to work, we have to have a Neo4j client bean present. So this means those are also available for injection, auto-wiring, how you want to call it. So I would say at this point, I make use of the Neo4j template, which offers me this more raw access to the data mapping, and not the good but reduced amount as the repositories would do. And with the Neo4j template, I have, for example, save as methods. Also, I have things like save movie projection is right, even though there's one movie. This pattern. Those are on the slides for future people watching this on the recording and want to follow along. This would have been a task, but I see the time, and so I do this right now and explain it during execution here. This would save a movie given only the visible parts of the projection. So it's quite analog to what we do when fetching data, that we say we go over all fields and all relationships of a certain entity and ask the projection, oh, did this get respected? If yes, okay, I will add this to the list of properties I will process. If not, I will just skip it. So this really is basically the same thing. But I hope you know. I hope you just trust me that I would delete my data otherwise. So, and just see that things are working, we will change the. That's harsh because I don't have any property besides the ID right now. Okay, for this we have a release here on the movie. I need to add this for a second because I don't want to adjust the query all the time. So the metrics is, yeah, I should know this. 1999. So I need to switch back. I forgot the name of the field. Released. That was what I'm looking for. What I was looking for. Released. So we also have this public final integer released. We don't do finals now. So I now have this released date there that I can say, okay, what probably was 1999. Movie released 1998, because very much earlier than everybody else knew. Only that you can see that this save method really does what we expect it to do. Yeah, I call this. We have the reduced amount of data. We alter one property, the release date, and save it via the projection. For this, we also, of course, need the projection to have this field defined. Otherwise, that's something we could try out here. I don't define the field right now. And we just execute the code. We have a look at the data here. And we can see nothing has changed. What we expected, because we have this excluded here. Now we add this released date. And hopefully everything went smoothly. We'll see in a bit. Oh, so sorry, it did not change. That's not what should have happened. Maybe I also maybe we have here to use save as. Sorry for this confusion. No. It should have worked. Yes. Perfect. But you know what should ensure this? Tests. We're just skipping this topic right now because of time. So Alex asked me to prepare something around 2 hours. That's why we are more or less top of the hour. If you have some time, we will just talk about testing for now. And maybe we can see how we put this in a comment, how to solve this. Because it should have done this way. And I currently have no idea why it's not doing it, what it should do. Talking about testing. As I said before, it would be good to have a Docker environment running, because the testing I want to show you is based on test containers. So maybe you've heard this in all other scenarios. We also provide a test container Neo4j module. That's also maintained by Michael and me most of the time. That should be up to date with common functionality, etc., and convenient functions to work with. For this, okay, first of all, we write some tests. Spring Boot test by default would create a whole application. If I only want to test my Neo4j specific functionality, or Spring Data Neo4j specific functionality, I can reduce the amount of infrastructure getting created by using a so-called test slide. In this case, the Data Neo4j test slide. This would ensure that we have the driver, we have the client, we have the repositories, the templates and the repositories getting initialized that we have defined in our production code. So everything that is unrelated, like a web stack or similar, won't get created. This makes the infrastructure for our test faster to come up and get tested. So here at this state, we could, for example, be doing this now the easy way. AutoWire a repository or a movie repository. We have a method we want to test against. So we have this ensure load with actors works. The custom query that we had before, just to have something under test that we have written as business code. Was this a title query? Sorry, it was this title query, right? Yeah. Just a little bit of formatting. So we want to ensure that the movie is not null, that the movie title is the metrics, and most of all, we want to ensure that we have all our actors in there. Five, probably five. So I could use the test as it is because, or I'm just running the test. So I can, of course, like, hey, that's the beauty of life. Yes, it's an interface. What's your problem? Okay, problems for later. We're just getting rid of the projection right now because I don't want to mess now with this problem. Hopefully this was the problem and not the embedded repository that we are accessing. No, perfect. So the test runs green, but we were using our production database. So the thing we have defined in the application properties here. Spring Boot conventionally supports also resource files in the test directory. That means we could create an application properties files for testing where we would point to a test instance. But shared instances are, as far as I would tell, not this good when it comes to parallel usage, because you would overwrite other people's data who are running also tests, etc. So we try to make our tests isolated. And for this, we are using today test containers Neo4j. It will take care of fetching a Docker container, spin up the Docker container, fetching the image, spin up into container with the proper configuration as we have set this before when we started the Docker container manually here. And a little bit of configuration. There's also a test container starter in Spring Boot available. You should really check this out. Also in Spring Boot 3, it gets, or in the upcoming version 3.1, it gets much nicer instrumentalization. That's why I excluded the Spring Boot features right now, because I want to show you only the test container itself and not some kind of infrastructure code that might change with the next version or might get even better with other functionality. And you are then using the older functionality or the older style. So I just added the dependencies for test containers. And then we start this container, Neo4j. with a image name, like the one I use locally right now. And that's more or less all you have to do. You could configure, for example, the admin password, like we had this was very secret. You could configure which plugin you want to run, if you want to run it without authentication, or you could even use random passwords. It all ensures that you have a properly configured, all the methods ensure that you have a properly configured container. It would complain before start if there is anything that would not match. So the database itself gets started. Also, we need to make sure, that's what I meant with instruction code that you have with Spring Boot. So then you wouldn't have to take care about this starting, stopping of the container. I just make it more explicitly now here because those might change. So we have the static container here. And also we make use now of this functionality of Spring Boot's dynamic property sources. Dynamic property sources mean that you can define your application properties after some infrastructure code when. For our case, for example, we have now the container. That's why we also offer the random password method. We have a Docker container that gets started where we don't know maybe the URL right now. We don't know the password because it might have been random, not just the set one, and other things. So we can then inject those properties directly into so our runtime properties directly into the Spring application properties. I just need to figure out right now one particular signature. Just give me a second. Fun thing I just have written about this. So I just need to come up with. Perfect. So we have then dynamic property registry, and this is okay. And this is more or less the same as we had this before with Spring, Neo4j, and it expects a provider for this. And at this point, we can access the informations from our database. Wow. Of course, we could also, I think, get the admin user. No. So it should be the fixed Neo4j right now. And the password, which could be randomized or something like this. So we start the container, we set the property, and after this, our driver bean and etc. will only get instantiated with the current information that we supplied here. Also, this should this should work as you can see, you have also some support for navigating around the code, that you have the right property names here. I'm pretty sure that I want to alter the test now because I don't have a test suite. You could do those things. I give you information about this in a second, but I'm pretty sure that the movie is now null because we don't have any data in there in another database. And to be really sure, I will stop the container, my local container. Yeah, it stopped. And run the test again. So the thing is, it should return null, but it shouldn't fail. That's what we're expecting here. Perfect. The red is perfect, I think. But before we come to the failing test, you can see the test container works. So we can see that they have some kind of observer image container running. There's an observer image, an instance of a container is running of this that will manage to fetch and communicate, fetch the right container we want to use, the Neo4j container, and communicate with this container. It's called this Y container. And then we can see why our test is failing. I still have this. Okay, sorry. It's still running, this method. That's why it's failing. Because everything that is within the command line runner will run nevertheless if you're executing tests or not. So this should really return. Yeah, perfect. A null movie because our database, as I said, is empty. But we ensured that the whole communication stack is working with the embedded Neo4j container. So if you have any questions for this, just ask. And yeah, then we're going back. First of all, I want to go back to the slides. Sorry for that we have not seen the persistence for the projections properly working. They should work. There's hopefully something you can trust me on. Maybe we can link this later. Hopefully you see the white, yeah. The white slides again. I skipped over testing. We had testing here. Yeah, I just want to mention there's more, but we don't have this many time. Reactive support, I briefly mentioned this, that we have a parallel stack running for reactive that starts with a reactive Neo4j client that sits then on the top of a reactive driver instance. And then also reactive Neo4j template, reactive repository support, such things. So you can use reactive types throughout and create a beautiful chain from your web stack down to the database. Then there are query methods for find by example also, where you provide an object how it should look like, and we will create the matching queries for you with the right conditions, etc. Yeah, and also just briefly time for this, the Fluent Neo4j client API that we haven't seen, but that gets used in the background. So if you want to learn more about this and you have questions regarding your current project, the best communication way for us, for really, I think there's a bug in SDN, is GitHub projects. If you have more general questions, you're sure that SDN should do the right thing, but it doesn't like you're using projections the wrong way or the Neo4j template, as I did, I would go to the Neo4j community. And if you just want to be getting informed by current development, check out the Neo4j developer blog. Everything said here was mostly focused on Spring Data Neo4j. Initially, I mentioned that we are also working on Neo4j OGM, but this is not the only project. We are also involved with Neo4j migrations. That's something you could use for database migrations, also for test setups, to ensure that your database has the right version where you want to test against. So we have migration scripts getting applied via Cypher statements, via Java code, just to name a few. There is a command line, the command line tool available for this. Also, we selected the Cypher DSL when we created Spring Data Neo4j in its current form. We wanted to have something more type safe to create Cypher statements with. Something that's aware of a match pattern, of the match clause, to know that a match clause can have a where, etc. So we have a fluent API called Cypher DSL out there that you can use. Also for those, the matching GitHub project pages exists. But if you have general questions about this, find us in the community and ask your questions there. Michael, more than I, currently published some blog posts also more with the focus on schemas, Cypher DSL, driver usage, and also general SDN topics on the developer blog at Medium. And that's pretty much all I had to say. So besides, thank you for your time and patience. I hope you had fun. I had fun. I know this. And you will have more fun after I've answered your question. I think. Yeah.
Cool. Thank you very much, Garrett. Sorry, everyone, for running a little bit over. But I think it was worth the time to include the testing at the end as well. We will share this recording as well as the slides with you later this week, so probably tomorrow afternoon. And so you can continue to watch this and to follow up during watching the recording. We have a few more things that are coming up. So there was a question from Andrew in chat. So I'm running regular live streams on YouTube. So if you follow the Neo4j YouTube channel, Neo4j, youtube.com/Neo4j, that will help you see what's going on there on the YouTube side of things, which are regular live streams with community members as well as some hands-on stuff. This indeed was the last of this training series. We will do a next series of training events sometime later this year. They are not scheduled yet, so stay tuned. You will be notified when they are scheduled next. Yeah, I think that's what we had. Sorry, that's what we had to say for today. Again, thank you for watching. Thank you for taking part. Thank you for your questions. Sorry if you couldn't answer all your questions during this, but as Garrett said, there is the community channel as well, the community forum. If you take the questions there.
I just see the questions. Can I answer them quickly?
We can. Yeah, of course. Yes.
Okay. So I just put Mr. or Mrs. or Carol in at once. So we have first of all the questions. Neo4j templates reduce content. Yeah. It reduces the content based on the projection. So as you have seen this in the oh, my slides are still open. Perfect. As you have seen this with the non-working example here, I wanted to persist the movie as the domain model, but I know that our fields are missing, that are not completely hydrated. But I give the templates information about, hey, it's a movie projection class I want to apply as a mask. So the Neo4j template just then checks for those fields. It's a little bit more complicated, but I think that's the simplest explanation I can come up with. Like, it goes through all the fields of the movie and checks back with a projection. Is this field defined or not? The field defined as in there is a getter method defined in the projection itself. That's one thing. So the Neo4j containers. The containers in general are, so the question was, what does, so here above we have this, what does this mean? So the containers, the test containers are typed containers, classes, definitions. So they are generic. That's why we also have to cater for the generic support for generics, even though if we don't define any type. Yeah, that's the only reason why we have to still carry this on. Yeah, it's more technical reason than something.
Okay.
Yeah. No, I for sure won't do this. Maybe it depends. Of course, it depends. If your use case, if your application's focused use case. Oh, sorry. Would you use projections for saving a class with many fields, for example, 50, that you wish to save, or just a few fields? It is use case dependent. If 80% of your use case is saving 50 fields out of your 100 defined fields, there are several questions that went up in my head. It's first of all, why you don't define your model with just the 50, and you make the 10% an exclusion when you have 100 fields, so that you do manually queries in there and map it to custom objects. The other way around, I would say it would be worth the work to define this projection with 50 fields if you really use it often. Otherwise, yeah, you shouldn't define 50 fields in one projections and 49 in another projection. I think that's not worth the maintenance in general. Then you would have to come up with some custom queries also for persistence to make better use of this. For me, projections are something where I want to filter specific for per use case, where I only have a few fields, where we can say, okay, I have these projections. I think about them. Are they combinable with over several use cases? That would be a good thing. If not, I will try to reduce the amount as far as I can to match every use case exactly if I only have a few fields or relationships in there. That's it. Yeah, I think that's the last answer. Yay.
Okay, cool. No, that just squeeze that in. That's great. Again, thank you very much for watching. I hope you enjoyed this. Thank you very much, Garrett, for presenting, for preparing the content, and for the demo. I think that was very useful and very helpful. Let us know if you want to see more of this in the comments on YouTube or in some other comments on the community channel. So that would be helpful for us. And have a good rest of your day, rest of the week, and hope to see you soon at another live stream or webinar in the future from Neo4j. With that, take care, everybody, and goodbye.